Okay, welcome to this tutorial. Today we'll be looking at longitude and latitude. So under longitude, we need to know the definition and the representation, location of points on the Earth's surface, distance between 2 points along the longitude, distance between 2 points along the latitude, and the shortest distance. So let's start with the first one, which is the definition. Okay, latitudes are imaginary lines on the Earth's surface. It varies from 0 to 90. So as you can see, if you see the globe, these are the pole, north, south, east, and west. So the line that runs from 0 to 90 up and down are called the latitudes. So, and it varies from 0 to 90. Okay, the one in red is called the equator. That's latitude 0. So why others, they are not 0? So they could be 10, 20, 40. So as you increase towards the north or south, it increases to 90. So the maximum is 90. So from 0 to 90. So this could be maybe 30. Maybe this is 60. So that's it. Why again, this could be 30, maybe 60. So it increases from the equator to north or south from 0 degrees. So this latitude 0 is called the equator. Okay, let me write. So latitude 0 degrees is called the equator. So that's very important. So let's look at longitude. Longitude are imaginary vertical lines on the Earth's surface. It varies from 0 to 180. So as you can see, we have, as you can see, they're running from, like the former one, the latitude runs from equator to north or south, but this runs from we call it prime meridian. That's longitude 0. So let's use this red one. This is called the prime meridian. If you don't call it, you call it Greenwich meridian. Greenwich meridian. So that's longitude 0 degrees. So we increase. Maybe if this is 0, this could be maybe 70. This is maybe 120 to what? Maybe 18. So this something. This maybe, if you take this as 0, so depending, 70, and this is maybe 150 to 180. So it runs from 0 to 180, west or east. Okay, let's move to location of points. So for us to locate any point on the Earth's surface, we need to know the latitude and the longitude. So the point of intersection of the latitude and longitude is the place we are looking for. So know that the intersection, to locate a point, we need the intersection of the latitude and the longitude of that place. So example, now if we are to locate, and mind you, we always locate a point, is always written latitude followed by longitude. So the easiest way to know is by So to locate a point, the first one is always the latitude, while the second coordinate, the first coordinate is the latitude, while the second one is the longitude. So as you can see, north, south, south. So whatever that you see here must be either north or south, while whatever you see here is either east or west. So let's now locate these points. So the first one, let me change color. Okay, let's use the first point. They say it's 60 north, 60 west. So the latitude, remember, starts from 0 towards north, so 60. So if I can, let me take this as 60. So we've located 60 north, because it's either north or south. Down here is south. So why 60 west? So look at west. So let me take this as 60 west. So that's it. So this point, the point of intersection, this is our latitude 60. So this is my point. This is my point. So this is point A. The point of intersection of 60 north and 60 west. So that's it. So coming to B, 60 south. Okay. Let me take this as 30. And let me take this as 60. So it must increase tonight. So I've located my 60 south. So remember, this is always up is north, down is south. Why 30 east? Okay, this is east. This is so let me see. Let me locate this. Let me call this as. Let me call this 30 east. So what's the point of intersection of 60 south and 30 east? That's it. Do you see it? This is the longitude 30 east, while this is the latitude 60. So this is point B. So as you can see, it's very simple to locate point. YC is 30 south and 30 east. So as you can see my 30 east, why this is my 30 south. So this is point C. So it's very easy for us to locate points. Once you know the longitude and latitude, the point of intersection becomes the place we are looking for. So let's now move to distance, calculating distance between 2 points along the longitude. So this is very, very important. For us to calculate the distance between 2 points, we need to know this, that the 2 points must have a common latitude or a common longitude. Yes. So for us to calculate the distance between 2 points, the 2 points must have either common latitude, if it's the distance along the latitude, or common longitude. So that's the first thing. So since we're on longitude, so they must have common longitude and different latitudes. So that's it. So we're on longitude. So assuming I want to calculate like this point. So assuming this is a longitude, I want to calculate distance along this longitude. So maybe if I call here A and call here B. So what do you notice? They must have common longitude and different latitudes. So if I call here maybe theta 1 of north, while here could be theta 2 of south. So that's it. And again, remember this is a sphere, like a circle. So and as you can see, the distance between A and B is the arc of a circle. So we can get the radius, the circle, because this is like the center. So we need the radius. So if we join O to A and O to B, we have the radius of the circle. So the radius of the circle is R, big R, which is, remember, if you notice, they are all big circles, so they are all the same. But for latitude, I forgot to say that, you notice that the radius is only this equator, that the radius is the radius of the earth. So is the radius. Another thing we need to know is that we need to get this angle. Yes, because for us to calculate the length of arc, we need the central angle. And how do you do it? So if you take this as, we need to, common sense will tell us that since they are of different hemisphere, that's not our south, you see that the angle here is the addition of these two angles, theta 1 plus theta 2. Because if we take this as the latitude 0, so if you move up, is theta 1. That's, I'm saying that if you partition this first part is theta 1, while the second part is theta 2. So the total angle is theta 1 plus theta 2. And if you could remember our formula for length of arc is always angular difference. So I'm saying that from here, AB, which is the length of arc, is always angular difference which is that's latitude over 360 times 2 pi r, where r is the radius of the earth. So that's it. So if they're of this, it depends. If they're of this same hemisphere, so assuming I draw, okay, maybe let me use the equation to explain that. Okay, look at this question. We're asked to, okay, look at this. They say 2 points A and B are on the earth's surface. Calculate the distance between A and B to the nearest kilometer. So see my globe. So let's locate the point. They say 30 knots and 30 knots, 30 west. So see the west. So if I take this to be 30, let's take this to be 30, or maybe, okay, let's take this, the red one, to be 30 west. So this 30 west. So they said 30 knots. So if I take this to be 60 knots, because I have 60 and 30, so this 30 knots. So the first A, the point of intersection of 30 knots, that, so the first one is this. So this is my A. Why my B is 60 knots 30 west. So the same 6. So do you see it? They have common longitude. So the distance is along the longitude. And this is my center, as you can see. So if I join the radius, this is my radius. So the radius is R, and R. So let's get the angle. So as you can see, the equator, the radius is 0. So if we start from 0, assuming, okay, let's take this to be the axis. So they said from here, from here to here is this 30 degrees. Have you seen it? So that's how we moved. 30. So this is 30. Why from here to that same, from here to here is 30 degrees. This is 30. Why from here to here is 60. So since here is 30, so the remaining should be 30 to make it 6. So 30 plus 30 is 60. Do you see the logic? See what I mean? Let me draw it out. We have something like this. So from here to here is 30 degree. Why from here to here is 60? This is 60 degrees. So meaning that here is 30, here it should be 30 to make it. So 30 plus 30 is 60. This is A and this is B. So we are to find this. So using our formula for length of arc, we can easily see that AB is, the angle is 30. That's the difference. 60 minus 30, that's 30 degrees over 360 times 2 pi r. So we take pi as 3.14 maybe 2.8 times the radius of the earth, r. We normally, the radius of the earth is always 6,400 kilometers. So we've used our formula 2 pi r. So we can calculate, this is, you can multiply, let me get my calculator. So if you multiply 30 times 2 times 3.1428 times 6,400 divided by 360. So the answer is 3,352.32. So this is 3,352.32 kilometers. So which is approximately 3,352 kilometers, because they say to the nearest kilometer. So you need to draw a clear diagram so that you can solve any question on that. Thank you.